it's important to reach out to the people and tell them, okay, if we move towards more wind, more solar, these are the options that we have in order to realize a sustainable infrastructure.
If you were to ask an industry outsider about what the energy transition is about, most likely they would talk about renewable energies such as wind and solar power. They probably would also mention electric mobility, and they might mention smart grids. And if you then ask them what a smart grid is, probably they have a vague idea about their electric car, their Tesla, being connected to the grid and not only being able to charge when power prices are low, but also maybe being able to feed energy back into the grid. Which of course is a fair definition of a smart grid, but it is only a very, very small portion of why smart grids are so relevant. So today, we want to go beyond the buzzword and give you a clear-cut definition of what smart grids are, why they're so relevant not only for electric mobility, but for the energy transition as such, and about the current technical status quo. Welcome to the Smartery Podcast, a podcast for and with the creators of the new energy world. A world in which energy will be renewable, decentralized and digital, bringing together electricity, heat and mobility. Let us show you how we will get there and who will get us there. Whom better to talk to than somebody who has dedicated his whole career so far to the development of power grids and whose actual job it is to come up with innovations for the global smart grid market. Dr. Michael Weinhold. He's the current head of technology and innovation at Siemens Smart Infrastructure. And he and his team are exactly focusing on that sweet spot where they're trying to match leading edge technologies in the fields of power grids with, for example, intelligent building concepts, as well as everything that digitalization has to offer to interconnect the various bits and parts. Welcome, Michael.
Yeah, thanks a lot for having me.
Michael, I had to look at your CV, and I think basically your whole career led to this point where you're at right now. But it all began somewhere in the 80s when you were studying to become an electrical engineer. And if you look at the 80s, of course, there was Chernobyl in 86. But apart from that, the energy turnaround really was far, far into the future. And as were all the technical opportunities we have at the moment, all the digital opportunities. So could you ever have imagined a world as we live in right now? And if you think back to your younger self as a student, would you maybe have studied with even more passion and energy, knowing that this is what you're training for?
Yeah, probably with even more energy, but I must admit that I always wanted to study electrical engineering, even as a small boy when I was tinkering around with electronics. So for me, electrical engineering, electronics, data, computers, that was always a passion and will be. So, but if I had known in the 80s that it would become so exciting, maybe I would even have studied with more eagerness.
Well, fortunately, you're still around in the same job and you have the opportunity to add on it on an everyday basis. So I really want to know from you now, because we always go from the basics to the more advanced questions here in the podcast. So to cover the basics, what's your definition of smart grids beyond what we usually use as the buzzword?
Yeah, Tage, so we can look at it from a technology perspective, or we can look at it from an, let's say, overarching mission perspective. And the mission we are having as a global community is reaching sustainability, and this with economics and with a security of supply. And that's actually, if you think about it, what smart grids are about. Smart grids are electricity networks that allow the intelligent integration of all the stakeholders and users connected to it, like generators, consumers, and prosumers, to deliver such a sustainable, economic, and secure electricity supply system. And then, of course, you can look also at a, let's say, technology perspective, and you will find definitions also on the internet about it, that it's an electricity supply network that uses digital communication technologies to detect and react, to forecast, to changes of usage of energy or supply.
So why are they currently so relevant?
The beauty of electrical energy is that it's a big enabler to reaching our sustainability targets. And why is that? Because the electricity grids allow the efficient and vast integration of renewable energies. You can transmit them very effectively and efficiently through the grids. down to the usage where, for example, cars are being charged, heat pumps are being supplied. So it's a very elegant and very effective system all around electrical energy.
And if I compare it with the conventional power grids that are already around, what are the differences and maybe also the advantages?
Yeah, coming back to when you opened and said in the 80s when I studied. Now, what were the grids at these times? We had basically conventional power generation. Renewables were around hydro. Solar energy was more or less for, let's say, satellite or very exotic applications. And you could also say that the grids were built as needed to supply the consumers and the loads, and the private consumer was more or less passive all over the world. And this has changed quite dramatically. Now we're integrating a huge amount of renewables on all voltage levels, from very small size like rooftop PV to very large size like offshore wind parks, with variable characteristic, and that has to be integrated and transmitted and brought to the usage of energy. And at the receiving end, you mentioned e-mobility already, we have more and more loads connecting to the electricity grid, because this is also one beauty I think I forgot to mention, that going into electricity, into electrical energy, typically raises the efficiency of processes dramatically. Just think about, for example, variable speed drives instead of mechanical drives, or utilizing heat pumps instead of conventional gas or oil burners. So electrical energy is a key enabler to reaching our sustainability targets.
So not only in order to get rid of fossil fuels, might be in mobility, maybe it be in heating in the housing area, but also because it's just so much more efficient than actually using fossil fuels.
Yeah, just look what we are doing with electrical energy. So we drive around in case of e-cars, for example, but we also run our computers, our data centers on electrical energy. And in a way, you see, it's this parallel pushing forward of technologies. On the one hand, you could call them the hardware technologies, to where electricity is produced, transmitted, and then transformed to heat or whatever, or motion. And then the data system accompanied to it in order to manage all this and to forecast it. And there will be more to come, as electrical energy is the key energy carrier for our sustainable future.
Since you already mentioned data centers, in my completely outsider point of view and my very basic understanding of things, to me a smart grid sounds much more complex, and in my eyes I would assume it's also much easier to tamper with or to hack. We just had this huge case in the USA where I think it was the gas pipeline provider was being hacked. So is that an increasing risk then as well with smarter and smarter grids? What's your stance on that?
Well, it's a risk, and this risk will not go away, and therefore we have products and solutions to mitigate the risk to the acceptable levels. So cybersecurity goes hand in hand with the build-out of grids, of smart grids. Okay,
so you just have to adjust. It's a new challenge, and you're very confident on being able to tackle it.
Yeah, and just as an example, in my team, in my technology and innovation team, more than half of my colleagues are cybersecurity experts. So they look into the IT processes, they look into the secure operation of our factories, and of course, they look into our products and solutions that we ship out to our customers. They do penetration tests and so on, so to make with utmost energy sure that what is out in the field is safe.
Which I guess really stresses the importance of cybersecurity in that area. So quite interesting to hear that you literally have 50% of your team focusing on it.
More than 50.
More than 50.
Yeah.
But that's quite interesting. So let's move away from the cybersecurity part and let's look about actually the stakeholders out there in the field. A lot of them are actually just basic consumers, such as maybe me personally having, for example, a solar panel on the roof, or maybe having an electric car. So I might be actually producing my own electricity. I might be using it. I might be storing it, feeding it back into the grid. And I think my use case would be, or if I'm a consumer, my use case would be falling into the so-called grid edge. And I think, which is another buzzword. So maybe you can explain that too.
Yeah, well, the grid edge is actually the interface between the electricity grid and the usage. And the usage could be, as you described, the feed-in of photovoltaic power from your rooftop PV plant, or the charging of your e-car, or the operation of your heat pump, or the operation of a building, of a complete building, like the HVAC system of a complete building. And this grid edge gets more and more interactive. And one word we should mention at this point is the word flexibility, because that is one of the key elements of the future system. Flexibility to take in the variable infeed of renewables and store it, for example, in thermal storage, or a building has typically a quite decent thermal time constant, so preheating, pre-cooling, that will become key in the future.
Actually, we had one of our previous episodes, we really focused on demand-side flexibility. So just a message to all our listeners, if you're interested in diving deeper there, yes, check out one of the previous episodes on demand-side flexibility. Maybe let's extend that grid edge a little bit, and also the stakeholders I mentioned in my opening. And I think it's something also I heard in one of the podcasts I found on your LinkedIn profile, is that electric mobility is probably the first thing that comes to mind, but is not the biggest part to play in a smart grid. Other areas such as industrial companies, infrastructure, buildings are much more relevant. Is that true?
If you look at where the end energy usage is, you'll see that, for example, in the European Union, around about 2/3 of the final end usage is around thermal applications, like, for example, space heating, space cooling, or industrial heat. And so to reach sustainable systems, energy systems, we need also to tackle this topic of how to provide clean heat to the applications.
At this point, maybe I would like to take a little technical detour, since there's so many various stakeholders involved. What are actually the requirements for power converters in the future grid to being able to supply all these different various stakeholders and different use cases? What does it look like from the point of view of a transmission system operators?
So now we are moving to power electronics, which is, let's say, one of my favorite topics, because if you think about it, wind and photovoltaics, battery storage, they interface to the grid via electronics, via power electronics. And power electronics or inverters or converters differ, of course, in nature compared to conventional power generation, because you sort of teach the converter how it behaves at the grid edge, to use this expression. You can, for example, teach it to just feed in active power and do nothing about reactive power, but you can also teach it to, if there is a reserve margin left, to also provide ancillary services, like, for example, reactive power support. You can also make it work like a machine having inertia, but of course, therefore, you would need some kind of storage on the other side of the converter. And this is just looking at the power electronics on the, let's say, feed-in side. If we go into the grids, and this was part of my commissioning engineer life, you can also apply power electronics to optimize power flows in transmission grids. And you can use them, like in case of static compensators, to stabilize the grid by providing reactive power support.
So that's clearly a topic that you're very passionate about. Unfortunately for engineers or also developers, suddenly they run into borders, usually when it comes to regulations. So what you just talked about, is it something in the hands of stakeholders who just can go out there and build it? Or does it really depend on the whole ecosystem coordinating? Who's in charge of it, and how easy is it to implement?
Yeah, how a converter behaves, or what you actually teach the converter and must teach it, depends on the governing regulation. And that, of course, also separates between the voltage levels where you connect the converter.
And so if you look at that, how far have we come in Europe? Because if I look, for example, at the German national grid, even just the basic conventional grid at the moment is a huge problem. We're not even being able to transfer all the power created in the windy north to the industrial south. So if you look at Europe as such, then I think the next level would be a smart grid. How close are we to it, and what are the biggest hurdles in getting there?
Maybe to start, you mentioned the, let's say, grid bottlenecks that we have in Germany, and this has been analyzed, also taking into account future supply and demand. characteristics, and we are looking towards 4 HVDC, high voltage direct current transmission lines, or cable systems running north-south to bring down the vast renewable energies from the north to the load centers in the southern part of Germany. And one quite exciting project is the so-called Ultranet project in the southwestern part, where existing transmission lines are converted into an HVDC line. So this is a power electronic application where power electronics are used to, at one point, in this case the northern part of Germany, take energy and transmit it to the receiving end, to the southern point, and inject it again into the AC system. And this shows one beauty of HVDC systems. You can very precisely take and inject energy at another point of the system.
And if I come back to the comparison I was trying to draw, is that in my eyes probably that's one of the more from an engineering perspective, the more basic things to implement compared to like the whole scope of a smart grid. Yet we still have huge challenges in getting it implemented, really from a regulation point of view, from citizens not wanting to have these huge power lines on their field, let's say that. So I was just thinking, if you then want to even make it smart, it's probably even more challenging. Is that true to say? Or is it not?
Maybe two aspects. Two aspects here. The first one is that HVDC systems and how the terminals of the HVDC systems work, they are part of a smart grid. And you can see it in the 10-year development plan or in the papers around what should happen in Europe. You can see there are several already existing HVDC lines and others being under construction or considered. So high voltage direct current transmission is in Europe and in other parts of the world already an established technology, and I would count it or include it into the, let's say, the box of smart grid technologies that we have at hand. The other aspect that you were mentioning, and I think we should touch on that one, is us as people. With our, let's say, wishes, what we want and what we do not want. And so this is really important, because one of the key elements of our future energy infrastructure is that we as people play an important role. We as people, we decide what will be implemented and what not. And therefore, it's for us engineers, and I think this podcast serves this excellently, it's important to reach out to the people and tell them, okay, if we move towards more wind, more solar, these are the options that we have in order to realize a sustainable infrastructure.
So it's really not only a technical process, but a democratic process. And there obviously still is a clear need to educate people what's at stake and why we not only might need to build wind turbines in somebody's beautiful landscape, but also HVDC lines all across the country.
If I may add, maybe one difference to the energy system we had in former times, which is not that far away. I talked about these central power stations, and typically they were, for example, in Germany, very close to the load centers. And if you look at the dimensions of those central power stations, quite compact. If you compare it now to a renewable power plant like a wind park or a photovoltaic power plant that produces the same amount of power and what is probably also as important, energy as a conventional power station, you will find that renewable power plants are typically, let's say, power plants that require a large surface, and they have a significantly more visible impact to the people than a conventional power station, which you can hide in a building. So the acceptance of the public with respect to renewables also includes the acceptance of large areas covered with PV and wind parks and wind turbines.
Which is interesting. I think a lot of things that have to do with digitalization, usually it's not so much a question of technology, but much more of culture, of change, and of getting people on board. And if we, just to dive into one very concrete example on the EU level, I think there's a project called Progressus, which tries to address more three of the more technical challenges, and that is efficient energy conversion, smart energy management, and secure monitoring. Is that kind of like a model project that you think is really relevant to create a unified approach across the EU?
Yeah, all this is very relevant. There are also other projects like the Prometheus project on EU level, which also looks into the promotion of these new technologies and how they can be ramped up faster. And they are typically basically about us as people, about acceptance issues. They are also investigating the pattern, the usage pattern, and the wishes. And this actually may differ from generation to generation. So bluntly said, we engineers, we have to very closely listen and communicate with us as people.
If I just dive into the EU level again, I think there's also at the same time there's a big effort being made to establish a Europe-wide charging infrastructure. So for pan-European traveling in your electric car, for example, how closely is that linked then to the effort to create also a smart grid across Europe? Is that one and the same? Are they happening parallel to each other?
That happens parallel and needs coordination, of course, because if you think about it, where are the big challenges in our grids, and the closer you get to the low voltage level, the bigger typically nowadays the challenges become, because the low voltage grid was, let's say, a very passive part of the electricity grid. So in former times, you could very easily forecast the usage pattern and build the grids just as they were needed with respect to capacity, for example. But as we discussed, nowadays, especially the distribution grid and the low voltage grid have become quite active. We talked about charging infrastructure, about heating, cooling equipment, connecting PV plants on the rooftop. Majority of, I think, 90% of the renewables are connected to the low voltage grid in Europe. So there's a big challenge, and it has to go hand in hand. When we talk about smart grid, this includes the integration of charging infrastructure. And you were talking about fast chargers, and they are very necessary in order to promote the application and the acceptance of e-mobility. Fast charging is a quite decent power flow. And just think about it. The average household in Germany probably needs, on the average, 1 kilowatt of power consumption. But if you connect a charger, and maybe an 11 kilowatt charger, and several neighbors do so, you see there's a challenge for the distribution grid. And that's also what a lot of projects are nowadays about, and also technology developments to control the downstream low voltage charging infrastructure, for example, or heat pumps very efficiently. And I could talk about a project where we are applying artificial intelligence in an intelligent substation in order to manage it.
Yes, please do that. That sounds very interesting. Yeah. Just take 2 sentences to share that.
Yeah. So what is it about? You have let's say, a dynamic state estimator, which gets trained in the cloud, and the parameters get downloaded to the neural network in the low voltage substation, and the neural network manages the charging infrastructure downstream such that there is no exceeding of voltage or current levels. In case the actual measurement values differ too much from the values of this state estimator, the neural network gets trained again. And this is could be very low cost but very effective solution to low voltage smart grids. And that's why we are prototyping it with customers like Stromnetze Hamburg.
So, and again, in my very basic understanding of things, what I took from the last 2 minutes was the power consumption would go up by the factor of 10 at least. If you said like an average household maybe usually using 1 kilowatt versus then 10 or maybe even 22 when charging the car. And if all of us do that, we just need an intelligence to make sure we're not all pushing the button at the same time.
Yeah, that's maybe a little bit simplified, because I was talking about average values, and of course you don't run your 11 kilowatt charger all the time. But in essence, you're right. Since we're moving charging infrastructure into our cities, that's very essential, into the apartment houses, the parking garages of apartment houses. We will have charging along the streets in our cities. We will have to see how we very effectively can accommodate the power flows. And part of it is, of course, having smart charging, so an interaction of the charger with a smart grid where it is connected to. Another one could be if there is a strengthening of the grid. This is actually a system planning task, and we are doing that also globally. these analysis.
With regards to time, we're coming almost to the end of the podcast already. So wow. I know it's a shame. I would have so many more questions. Exactly. It is a very complex topic. So thanks a lot for shedding some light into it.
You're very welcome.
And helping us to understand the first basics. And of course, if some of our listeners really want to dive into the level of understanding that Michael has brought into this conversation, feel free to connect with him on LinkedIn. I personally saw he posted on a regular basis. So there's some very interesting case studies in his profile. Thanks a lot for having joined us today, Michael.
Yeah, thank you, Takis. It was a pleasure. Thank you very much.
Stay tuned for more episodes of the Smarter E podcast. You can find many more exciting presentations on energy intelligence and smart grids at the EM Power Forum, taking place as part of the Smarter E Restart 2021 on October 6th to 8th, 2021 at Messe München. All information is available on em-power.eu.